This video was produced by the UCD Maths Support Centre in conjunction with the UCD Access Centre. In this video we're going to talk a little bit about finding the angle between two lines, but in order to do this first we need to talk a little bit about what the angle of inclination is. So the angle of inclination is the angle between any line and the positive side of the x-axis. So you can see in these diagrams below that in the case of this line here, the angle of inclination is this angle here. This angle, call it theta. If you have a line like this, the angle of inclination is not this small angle between the line and the axis. It has to be between the line and the positive side of the x-axis, so that would be this angle here. Another thing to note is that the slope of a line is equal to the tangent of its angle of inclination. So if we take this example that we had back here, this picture on the left here with this line, if we were to look at this angle theta here, and we were to draw in a right angle triangle here, we would see that if our right angle is here, that our x distance here and our y distance here are related by the tan of theta being equal to our opposite, so our y over our x. But this is just the exact same thing if we're talking about the slope of a line of this line here as being our rise over our run, which is our slope. So that's where that comes from, that the slope of the line is the tangent or tan of the angle of inclination theta. Tan theta is our slope. So now we can talk about the angle between two lines, and it's given by this formula over here. Tan theta is equal to plus or minus m1 minus m2 all over 1 plus m1 times m2, where that m1 and m2 are the slopes of the two lines. What needs to be kept in mind here is that this theta here, that we figure out from doing tan inverse of all of this stuff, is actually the acute angle between the two lines. So that is, if we have these two lines, like I have here and here, here, then you'll see that the theta angle that we find in our formula is actually the acute angle here, theta, this theta here. So we have to keep that in mind when some questions might ask for us to find both angles. So in order to do that, once we find our angle theta using our formula here, we can find the obtuse angle by just doing 180 degrees minus our theta. So now we'll take a look at an example. So in our example here, we're asked to find the measure of the angles, so both angles between the two lines 2x plus y minus 6 equals 0 and 3x minus 2y plus 2 equals 0. So what we must first do is to take a look at our two lines and to get their slopes. So looking at our first line, 2x plus y minus 6 equals 0, our slope for any equation like that is, if you recall, minus a over b. So in this case, Our a is the number in front of x, which is 2. The number in front of y is just 1. So we have our slope there as being minus 2 over 1, which is minus 2, and that's our m1. Then, when we look at our second equation, 3x minus 2y plus 2 equals 0. Our slope there is minus 3 over minus 2, which is 3 over 2, and that is our m2. So once we've found m1 and m2, we can write down our formula for tan theta. We can fill in our m1 and our m2, our m1 being minus 2 everywhere, and our m2 being 3 over 2. Sorry, not minus 3 over 2, just 3 over 2. Then we can just simplify our fraction here to get that tan theta eventually is plus or minus 7 over 4. Then, in order to get the acute angle theta, we just have to get tan inverse on both sides, and tan inverse of 7 over 4 on your calculator is 60.26 degrees. Then, to get our obtuse angle, which is what we're asked, since we're asked for both angles, we require our obtuse angle, and we get that just by doing 180 minus our acute angle, 60.26, and that answer comes out to 119.74 degrees.